Welcome to our Elvaco webinar, Beyond Data, Heat Metering with LoRaWAN. Today's speakers are Hannes Güttler. He is Head of Energy Management at Kelag in Austria. And I'm Florian Schmidt. I'm the Regional Sales Manager DACH at Elvaco, and I will be the moderator today. Our agenda today will be the introduction. Then we will show you the vision and mission of Elvaco, also highlight the LoRaWAN technology brief. Then Hannes will take over and share from the daily life network design based on use case, also show their use cases at Kelag in Austria, and also explain the results, what they have learned. In the end, I will round the topic up and bring the LoRaWAN solutions from Elvaco and show them. And in the end, we will use some minutes to answer your questions. So please feel free, write your questions into the chat. We will be happy to answer them. Elvaco's vision and mission. In the European Union, 40% of the energy consumption is based on buildings, and we at Elvaco, we will help you to make this data accessible with our solutions and help you to increase efficiency. And in the smart city, our contribution will be the buildings area and the utilities area, as you have seen in the mission. And Hannes is place of smart city, takes part of in the smart city in the utility area. And as you know, LoRaWAN covers the whole smart city approach. So we are focusing on the smart metering area here, but nevertheless, you can use also LoRaWAN to get data from the whole smart city. Elvaco provides an end-to-end solution, and this is split into 4 product groups. The first group is sensors. Here you have the possibility to get data, for example, like temperature, humidity. Then we also have a group, it's called meter connectivity modules. Here you can retrofit your meters with plug-in modules from Elvaco to get data out of the meters. Beside that, we are also well known for our infrastructure products. Here we are well known for M-Bus and wireless M-Bus gateways, splitters as equipment and other equipment. The last but not least is the Elvaco Evo family. Here is our cloud service linked to, for example, you can analyze your data, your metering data with some nice graphs in there, or just process data to your billing solution. Also, we are handling all our product life cycle in a digital way there. So, for example, key management solution is also included in Evo. Now we are coming to our history. Soon the company is 40 years in metering business. We were founded in 1984 at Elvaco, and today our headquarters is in Sweden. We have around 60 employees. We have a local presence in Germany, UK, and Spain. So there you can contact Elvaco people in your local language. Beside that, we have a wide partner network. So if you check out on our website, there are many Elvaco partners mentioned, which you can contact locally as well in your own language. Please take the chance to contact them as well. Beside that, we are also member of the OMS group and the LoRa Alliance. Here we help the people in the standardization procedure with our experience from the metering. LoRaWAN technology brief. What is LoRaWAN? As you know, LoRaWAN is a smart city technology which you can use to get data from sensors in the network and to transfer it to your software in the end. This is in general, and LoRaWAN originally came from smart metering. So you can use it to get data from meters in the end for your billing procedure, for monitoring purposes. LoRaWAN in the European Union is based on 868 megahertz, and this is used to get the data into your software solution. It is known for high energy efficiency, so you can use a battery for in smart meters, especially interesting for water meters or heat meters to get data. It's having a high range. Here you see some use cases from Hannes later on, how you can set up your LoRaWAN network in a smart way, that you get a good range and also deep indoor penetration, so data also out of basements. On the other hand side, it's also known that it's having a low bandwidth and limited data. This means you are limited around 51 bytes. But this is perfect for smart metering applications, so you can cover all your use cases from water metering and also heat metering to transfer data. Beside that, we are in a license-free frequency spectrum, so you can build up your own network, or you can change your network provider, so you can also outsource this. This is a super interesting thing. LoRaWAN architecture and security. There are end nodes. So for example, you have meters, then you have a data concentrator to read the LoRaWAN data. Then in the end, you have a network management server, which is managing your gateways, reading the meters. So optimizing, you see this here. So the network management is the brain and is optimizing the reading performance. And in the end, handling data and bringing it to an API. And at this API, you can collect data with your, for example, billing software or metadata management software to visualize data. And what is super important is that this is end-to-end encrypted by an AES security encryption layer. So your payload, your metering data is safe and is encrypted by 128-bit security. Also interesting is that LoRaWAN is having different session keys. So one is the application session key you have seen before, which is good for this end-to-end security. The other one is the network session key, which enables you to outsource this area, for example. So gateway handling, gateway management on site, and the network management could be done by a third party. So this could be a partner, maybe like Kelag or anybody else. And in the end, your data is still encrypted. So it's possible to hand through your data to your software solution in an encrypted way, and the network provider does not see data. So that's also a very interesting highlight of LoRaWAN. So now it's time for Hannes at Kelag to take over.
Thank you very much. Hello also from my side. A few words to me and my company. Kelag is a local energy supplier in the south of Austria. And I'm responsible in the part of district heating, and we came from the metering world, and we started in the beginning of this century with the automatically readout of our heat meters, in I think 2008 we had already 100% of our meters with automatically read out based on the wireless ambers. And in 2017 we started the cooperation with Elvaco. We bought the first meters and the first modules, and in the meantime we decided to change all our readout, all our meters to LoRaWAN. So we are driving 90 district heatings in different cities here in Austria. We are the biggest supplier there, and when we started a project, I just want to tell you a little bit out of practice. The question is on the very first beginning always the security. Where are my data? Who owns the data? Where are they stored? And as Florian mentioned, the LoRaWAN network and the LoRaWAN architecture is really in that case that the data are really secure, and the encryption decides the customer itself. So I have two roles in that position. We are, and at the one hand, we are the connectivity provider. So we are building networks, we are building LoRaWAN connectivity, and on the other hand, I am customer. So I use this network, and I use this network for my own readout of heat meters, and then we'll mention it a little bit later for the different IoT applications. What is very important on this LoRaWAN is also that this is a bidirectional communication, and all these security information and these security layers are in both directions at the same part. So we are not just receiving data from the meters, so we are doing also activities with the LoRa signal. So we are acting to shut off or to valves or whatever, or for example different things on the network, and the customer decides where the data are encrypted, and so the position is that we give the customer just the encrypted data, and they work then on their end application and do their business for their own. But when we jump into the first part, the next step go ahead and so how to build a network, and the questions always are where we could install the gateways, where we found the optimal locations. And where are the best position really to cover an area with LoRaWAN network to build up a readout of really of a network. And at the very end, okay, of course, the how many gateways are needed, and this is then the cost calculation for the project, and this is the cost calculation for the project, and the decision: do we build a network with our customer or for our own? And the question is any time do we get connectivity to our meters? And in the very beginning, we decided to the experience we had from the normal wireless Ambus readout, we have to do a simulation. We have to do a calculation, and the problem is how we get this information. Are there some software tools available to design networks to calculate the connectivity to get the information where we build this? And there are many influences. So to get this information to come really to the simulation, and we checked out this, and there was no simulation tool available on market. We get an information and an idea about these irregular terrain models out of the TV broadcasting and the radio broadcasting, but they have also always just the simulation of the propagation on over the surface, because none of these simulation tools are working really in that case that we have. Our meters are 2-3 meters under the surface, so we had to calculate in a different way, and then we said, okay, we have to do the calculation on the normal terrain. But we have also then a use case with indoor application, and we have also this deep indoor application, and we have to calculate also this deep indoor, because this is our main use case. The meters are above the surface. So then there was the only way was to design an own simulation tool, where we set all these parameters with the model handling, with images which we bought, which we get, for example, from Google. Then did the calculation, and with all the possible influences from packet loss, from path loss, from the attenual values, and output of this was then an raster, which we which I want to show you in a special example. This is the city of Villach. City of Villach is our home place, and here we have partners. And for example, the water management of the city of Villach gives us the yearly goal, and said, okay, these are 2,500 meters. This we want to install next, and with this we want to change next year. And for this we need a LoRaWAN connectivity. So then we are sitting together with our customer, check out the area, and then we made a small overview to check where are the best position. The first question is, do the customer have some sites where we could mount these gateways? Second question is, do we have as a district heat supplier sites where we could mount the gateways, or are there some places where we could mount these gateways? In any case, we try to find the highest position for our gateways to cover the area, and to set up the connectivity with the LoRa network. Out of this, there are then some positions, some sites where we check this and said, okay, with this we should cover the area for our customer, and with this information then from area, from sites, from building, from all the information I mentioned before, we calculate the coverage. And as I said, the coverage of normal rural area, or indoor or deep indoor. And the deep indoor calculation is just a matter of gateways. It's just a matter of the amount of gateways. So with the deep indoor, we have here, for example, we reach 300 meters to 500 meters connectivity on the LoRaWAN, and in rural areas we had 20 to 30 kilometers communication without problems. Then this is the calculation. We get the feeling that this is perfect. We mount the gateways, and when the gateways are mounted, the meters are installed, we check this calculation. So we designed some tools. We designed some checkout. For example, this visualization. We every meter. We check every meter from how many gateways we reach this meter. So this is then a matter of the site quality and of the signal quality, and at the very end, then if we don't reach meters, in case that we have to set up 100% connectivity, then we have to install several gateways, but then we use normally not outdoor gateways that we mount on sites as high as possible. If then, for example, we build an indoor gateways just to cover the bad situation, and the meters which we didn't reach due to the simulation we had. And all this information come back to our calculation tools, and for the next calculation we get the feedback, and we check out yeah, now we are doing this 5 years, and the calculation, the simulation always gets better and better, and yeah, we're able really to check out. For example, in Villach right now we have 10,000 water meters from the city of Villach. We have 1,000 heat meters from our own district heating. We have approximately 15,000 of these heat cost allocators in Villach, and several IoT use cases and application, which I will mention then a little bit later. But this visualization, these tools are very important for us then when we are driving the network, really to check the propagation, to check the distance, and even to get a benchmark for the gateways and the connectivity to each heat meter itself. When we have then the data, this is our main work. We have then the possibility to analyze the heat meters. At the moment, we are collecting the values every hour. To check out really the need of our basic work. Because you know, in the district heating there is the morning peak, and within the morning peak this is the most interest from our side. So when is the latest point? When is the latest time point to bring the heat in the network, that every customer get the amount what he needed, and that we could drive the network efficient and very efficient. So we are really checking then the efficiency of our heat plants, but within this information, within this hourly rate, we have a very fast failure analysis. We have then data-based decision possibilities, and we have then new possibilities to detect anomalies, to detect failures, and we could react very quickly. So this is then output of our work, and we are checking the heat meters according to the laws, really with hourly rate. But we cancel these data very soon. This is just for the first analyze, really storage, storing and working. We are then doing with the monthly, the daily, sorry, the daily values, and because we are not allowed to store these hourly values for a very long time. And then output of this is then really an error analysis, for example, which we get our which get our service technicians, and we have then really the counter check, the error code, everything we get very quickly, and we could react immediately and check out and drive the network, the district heat network in a very safe way. This is the overview we have for the district heating, and right now we are in the position that we have the first heat meter change. We started as I said in 2018, and the first meters are now really in the change position, and they worked since that really perfect, and we have absolutely no problems. And this was the first generation of LoRaWAN modules we get, and together with Elvaco, we did really a big development and some tests with different suppliers of heat meters. But the very first with Landis working now for us 5 years properly. And we have then, on the other hand, a second business with the possibility with the LoRaWAN itself. So LoRaWAN is not only for the meters. LoRaWAN has also a lot of applications in the IoT business, and the IoT business in our area is growing immense. We mentioned now all these smart meter from water, heat, gas, even electricity. This I showed you before, but on the other hand, we get really a lot of use case of application in smart environment, smart city application, more and more in safety and emergency use cases, and all the information I summarized here on that slide from really, for example, smart city parking, traffic, road conditions. We installed here in industrial partners, in communities. Here in Austria, for example, it's very common to use a weather station in combination with the snow height to calculate then the winter dienst, so for putting the snow away, are more and more than in safety and emergency, really for room conditions and conditions really in outside. So due to the COVID situation, the CO2 position, the measurements are very important. And right now, our group, and this I think is a very important information. We have 40,000 gateways in use, and we are receiving millions of data with this because we have right now I think the exact number is at the moment 6 million sensors and then meters which are working with our LoRaWAN network and with our LoRaWAN connectivity. This, from my side, a short overview. I give the presentation back to Florian. I think there are a lot of questions later on, which we want then to hopefully we could every then answer and go then in some details. But this from my side, so as an overview, what we are doing and what is in practice, then the situation to set up to build a LoRaWAN gateway and how we work and which applications we use here in our company.
Thank you, Hannes. Thanks for sharing your experience. I'm looking forward for the Q&A session to discuss the questions of participants. Let's have a look on our LoRaWAN solutions from Elvaco. So as Hannes said, we are also part in this network, part in the heat metering environment. We at Elvaco, we are well known for our heat meter LoRaWAN portfolio here. And the big advantage is here, if you qualify once our platform, you can read out all heat meters with our modules. We are providing the modules for the biggest European heat meter producers. We are using world-class security, which means we are based on the LoRaWAN security standard and using the highest possible standard there. And what is also very interesting beside LoRaWAN is you saw the map of Hannes. So you have somewhere your network, and sometimes around you have some dots which you cannot cover maybe with LoRaWAN. And here it could be interesting to add to your heat meters on site our upcoming narrowband IoT modules. So maybe the last 20, 30 heat meters you could cover with also a retrofit plug-in module, put in a SIM card, and then read them out. And at the moment, we have already from Landes and from Deal, we have the modules in place. But beside that, we also bring for Canstrup and iTron a module after the summer vacation. And all the modules you see come with a 10 plus 1 year battery lifetime warranty around. So this could be also very interesting for your project calculation, for your total cost of ownership calculations. What I also would like to highlight is more to come means we will release more and more products in this environment. So it is good to just go for LinkedIn and keep track on the Elvaco movements there, or maybe on our website. So now it's time for the Q&A session. So I saw already some questions in the chat. So let's see. One of the questions, Hannes, was, the first one was, which gateways have you used in the project and how many?
Okay, we use different gateways. In general, we use the Zenna gateways, the minor Zenna gateways from Germany. These are mainly our outdoor gateways. We have also then indoor gateways. In that case, that just a building, or that we have to cover a building. We have a very small gateway, which is just more or less a private use, which communicate over the WLAN from the private situation, and at the other end we have also then gateways which we use with direct satellite communication. So because in areas for civil safety reasons and emergency reasons, we cover area without mobile connectivity, and so for this use case we even use gateways with the direct satellite communication. And I go through a little bit of the questions, and I will explain the amount, how many gateways we use. In general, I said, okay, we have right now 40,000 gateways, mainly in the business of the heat cost allocators, and especially for Villach, for example. We have Villach is a city with 100,000 people, and we have for deep indoor coverage 21 gateways over the whole city. And as I said, we had a readout of 10,000 water meters, 1,000 heat meters, and the heat cost allocator, but we have also then different use case, more or less than based on IoT, but we do also, for example, then this sorry. We check the pressure of the water network, and also of the heat network with LoRa gateways, and we have some radio control devices where we check leak detection in the network, and they are always in a very bad positions. So with the baddest connectivity where you could imagine. And for Villach, we have 21 gateways to cover everything to get really 100% connectivity. And for example, the calculation I showed you in the presentation for these 2,000 heat meters, after installing gateways, after installing the heat meters, we just we didn't reach 2 meters. That's true. That's really due to our calculation. We just get with 2 meters no connectivity, and then you have to check. And there are also then different possibilities. We changed the modules from Elvaco, not with the internal antenna. So then we change, for example, with the external antenna. So then we go really to the location, really to the position where the meter is, and try to make the situation better, to communicate with this heat meter. But on the other hand, maybe then we have to install a different gateway next to the position where we don't get connectivity.
Mm-hmm. And this is all deep indoor connectivity.
This is all deep indoor connectivity, and we have for deep indoor with the outdoor gateway we cover an area of 300 to 500 meters, and really on a rural area we covered up to 30 kilometers. So this was our experience, what we have. But the calculation, as is saw on my pictures, the green area is 300 to 500 meters, circular meters, and the yellow one for indoor application is up to 3 kilometers.
Mm-hmm. Okay, thanks.
So
yeah. So regarding network management server, we had a question. So which LoRaWAN network management server are you using for this private network?
We also using the Minolzena, this Minolzena Connect network server, and this was an development with from our partners, and yeah, this is our network management, our servers which we are using.
Mm-hmm. Regarding the analysis software, so was your analysis software internally developed?
Yeah. So as I said, we have we checked out on market, and we just get the simulation tools from the TV, from the radio broadcasting, and they have no part that they have to cover deep indoor, and they are just in direct connection, and the simulation could just do that part, and none of them could do this indoor calculation, this deep indoor in the ground, and so we set up this software for our own, and yeah, really worked on that. It's for 5 years, and I think now we are in the status that we said, okay, the calculation is really also used in practice. And as I said, in this project, what I mentioned in the presentation, we just didn't get 2 meters.
Mm-hmm. I see. Cool. Another question was, maybe you can help me here a bit. What is width diameter, RIT diameter, and P diameter?
I don't know what with width and RIT was mentioned, but I think this was the diameter I explained with the green one, with the 300 to 500 meters, with the yellow one in the indoor coverage with 500 meters, and okay.
In a heat meter analysis, nothing with LoRaWAN, he writes here. Okay. So I think this was one of the tables. Just a sec, I jump back. Maybe this one on top. Yeah, okay. I think return and forward temperature could be on this on top. Here, this area.
Yeah.
What are those values? Maybe to explain again.
Okay, yeah, the meters in their protocol have also the failure information, and you know, from the customers send then the error code from 1 to 9, and the error code is then sometimes error in the measurement system, or there is no communication possible, or the temperature sensors are maybe changed during mounting, and this code we also transfer with the LoRa information, with the LoRa protocol, and this is then an error analysis which we get, which our service technical get to react immediately and find the problem and solve this as soon as possible.
And the other part of the question was the last 3 columns. So it's those values. I think that's temperature.
Okay, this is temperature. And we have some rough calculation. So for example, the first is the temperature from what we get back, but there are also a factor of temperature and flow, or energy and flow. So this was the calculation we had in the past, and which we check. But more and more we took KI and ML for analysis, really to check immediately, and to get special profiles to check if is it possible. Then, for example, we do then analysis really to get immediately the feedback from the problems, and really to make better prognosis, and to check really the value, if the meter measures correct, and if at the customer side is everything okay. And so more and more we come in this automatic anomaly detection and automatic alerting due to the KI and measurement learning rules.
And you especially look here, so far I can see, on the return temperature. So the forward temperature is nice to know, but mainly the return temperature is very important for you here.
This is the main parameter for driving district heating. The better is the lower, the better is the temperature. The back.
The lower, the better it is to save money. Okay, thanks. Cool. Another question was, okay, maybe jump back quickly again. So these numbers are forward temperature, return temperature, and power. I would say yes, or?
Yeah.
Okay, cool.
But this is just an example. There are different analyses possible with this. Yeah.
Cool. Okay. Another question was about packet loss rate. So this is about LoRaWAN. So can you please comment something about packet loss rate versus distance?
This is very difficult. I had also, and so we had also and check. I have to if there is Florian, go please back to the slide visualization of the LoRaWAN network.
So this one, you mean?
No, visualization of LoRaWAN network. This is go on. Okay, then go on. Okay, I took the so okay. And here you see also then average package loss, and you see then this with this is also the biggest we have, and this is just for this gray with where we get the connection just to one gateway, and yeah, if it is a problem in that loss rate, then we have to change the position of the gateways, or we have to react in any case. But yeah, this is when you see the connectivity with the RSSE and the SNR value, they are quite really bad with minus 130 and minus 6.9. So with this at the very end of connectivity, we have a packet loss of 40%. So this is really the better situation we have. All the others where we reach from several gateways, it's much better. But these are really true numbers, which are really true numbers we are working with.
So it's you always have the possibility to improve, to relocate a bit gateways, maybe to turn antennas, and then you improve the situation.
And depends because you know when as I told, we made the readout hourly. And with this hourly rate, then we could decide, okay, if I then if with 40%, then I get maybe, for example, 3 hours a day, 4 hours a day, no values. Is this important for me? Yes or no? For meter application, for meter use case, it's not necessary to do anything. Maybe in the IoT business for special information, we have to do then here and make the situation better.
Okay, cool, thanks. So I see no further questions. Oh, another one came in. What is the transmitter lifetime with hourly values? So means the lifetime of the module. The battery
5 years. So I could just tell from the Elvaco the longest part we have with the Landis heat meters. They are right now 5 years in use. 5 years in use. Yeah.
And beside that, if we use the eco mode of Elvaco, so the data sending interval is up and down, then it's
this is an information, but this is a specialty of us. We don't use the eco mode. Because we want to get every count. We want to get every value, and we due to the situation where we are to analyze really the peaks and to analyze the situation we have. So if I lose some packages, it's not important. My KI will fill the values, but I want to get as much information as possible to get feedback to my calculation, to get feedback for the data-driven process we have on the district heating itself.
Okay, thanks. Another one.
Yeah.
The multicast groups.
No, because we have our own network. I don't understand this.
I think it's because if you change when you change the gateways, maybe like in this direction, maybe. So I think that's controlled by the network management server. So,
yeah. Okay. But yeah. This.
The downlink then.
Elvaco support this, and we do this. So we did the change on with the downlink, and this I said, okay, the important thing on the LoRa is on one hand really the bidirectional communication, and we did the change every time with a multi signal on downlink to change them. Yeah.
Yeah, so you put the command to the network management, and then it pushes out automatically by the downlink, and then the configuration is done.
Yeah.
And related to the eco mode, you can also disable the eco mode by this downlink, and then include.
This we have. So all our meters are eco mode disabled, and because we want to get the information for analysis, and maybe we will check this or we will change this later. But right now, at the moment, for us, we enabled the eco mode.
Okay, cool. Thanks. So then, thanks for your participation. Was a very nice webinar. Thanks also to Hannes for sharing the experience from the daily life and also from this real project. I enjoyed it a lot. If you would like to get further information, don't hesitate. You can click on the link later on in the slides we will share, and then you see the local sales contact in your area, or you check out on our website in the partner area who are the partners in your country. Then this partner will be also happy to support you and help you with your LoRaWAN solutions. The last but not least, if you would like to contact me directly, you could also contact me directly. You see my mail address here. I would be also happy to assist you and answer your questions. So thanks for this webinar to Hannes. Thanks for your participation, and wish you a nice day.